Hello students, today we're going to study the ionic bond. In my last video, I explained the covalent bond. Today we're going to talk about the ionic bond. Both covalent and the ionic bonds are strongest bonds. Ionic bonds form between two or more atoms by the transfer. So here it could be loss or gain. So one atom loses electron, the other atom gains electron. So one's loss is other's gain. So there is a transfer of electrons between two or more atoms. Okay, there can be two or more atoms involved. So we know an example which is NaCl, which is common salt or table salt that we use. Here there's only one sodium atom and one chlorine atom. But then there is another salt which is magnesium chloride, where you will see one magnesium and two chlorine atoms. So there can be two or more atoms involved. The transfer of electrons result in charge on the atom. Now atoms are electrically neutral. They do not carry a charge. Why? Because the number of electrons is equal to the number of protons. Now electrons are carrying the minus charge and protons are carrying the plus charge. So if the number of electrons is equal to the number of protons, then automatically an atom is electrically neutral. But in case if the number of electrons is more than the number of protons, then the atom becomes negatively charged. If the number of electrons is lesser than the protons, then the atom becomes positively charged. Okay, so the transfer of electrons result in the change in number of electrons, results in the imbalance between the number of electrons and the number of protons. Hence now the atom will carry a charge. Such charged atoms are ions. When an atom loses electron, it acquires a positive charge and it is known as a cation. When an atom accepts electron, it acquires a negative charge. It is known as an anion. Now, if you have an atom, for example, we'll take an example of sodium. So, sodium loses one electron and then the configuration is 2 and 8. So, what is the number of electrons before it lost one electron? Was 11 electrons. Okay, before it lost an electron. After losing an electron, it has 10 electrons. But protons are always in the nucleus. Protons don't leave the sodium atom. Protons are going to be inside the nucleus. The number of protons is 11p plus. But after the loss of an electron, now sodium has only 10 electrons but 11 protons. So obviously the number of protons is higher than the electrons, and hence sodium atom now becomes a charged ion. Okay. Similarly, when an atom accepts electrons, so for chlorine, the configuration is 2, 8 and 7. After it accepts one electron, the configuration becomes 2, 8 and 8, which means initially chlorine had 17 electrons and 17 protons, but after accepting an electron, now sodium has 18 electron but 17 proton. So you will see that the number of electrons is higher than the number of protons, and hence chlorine acquires a negative charge. So it becomes a negatively charged ion. Now, a negatively charged ion will always move towards anode, will always go towards the positive terminal, will always be attracted towards the positive, which is the anode, and hence it is known as a anion. A positively charged ion will always be attracted towards the negative terminal, and hence it is always called as a cation. Ionic bonds are formed between metals and non-metals usually. If you remember the covalent bond video, the covalent bonds are formed between two non-metals or a non-metal and a metalloid. Here it is always between a metal and a non-metal. So the metals always tend to lose electrons and they acquire a positive charge, and hence they are known as electropositive. Non-metals, they have a tendency of gaining electrons. Okay, why do you lose? Why do the atom lose, and why does the atom gain electrons? It is because of completing a duplet or completing an octet. Okay, this is also because they are willing to achieve stability. So non-metals will gain electrons, okay, and they will acquire a negative charge, and they are known as electronegatives also. So always metals are electropositive because they donate electrons, and non-metals are electronegative because they accept electrons, or a single electron or two electrons. Ions with opposite charges will attract one another, creating an ionic bond. When you look at a compound like sodium chloride, sodium is a metal, chlorine is a non-metal. Sodium will lose electron, it will acquire a plus charge. Chlorine will gain electron, it will acquire a negative charge. Plus and minus attract, and then you will get a compound which will have an ionic bond. So here, this bond is an outcome of attraction or force of attraction between the two oppositely charged atoms. Ionic bonds are also stronger. They are also stronger than hydrogen bonds and equivalent in strength to the covalent bonds. Both these bonds, covalent bonds and ionic bonds, are considered to be stronger bonds. Formation of ionic bond. Now, is it exothermic? See, transfer of electrons or acceptance of electrons for an atom does not come free of cost. It costs energy, and it is energetically unfavorable. Okay, because if you go to the market, if you want to buy something, obviously nobody is going to give that for free. You will have to spend some money. So you give money and you buy something. So obviously, if you are losing an electron, if you are gaining an electron, that is not free. That will cost something to the atom, and that is energy. Now there are two types of energy that we are going to see here: ionization energy and electron affinity energy. The amount of energy required to remove an electron from an isolated atom or molecule. So, when an atom is converted into an ion, either it loses electron or it gains electron. So, when it loses electron, let us see what will happen. In case of, again, I go for the sodium. So, this one electron is lost, or this one electron is removed. Why? Because this is the K shell, this is the L shell, and this is the M shell. In this M shell, there is one electron. This one electron is removed. So after the removal of this one electron, sodium is stable, duplet, and this is the octet. Okay, so the energy which is required to remove this one electron from this particular atom or a molecule is called as an ionization energy. Now, what is electron affinity energy? The amount of energy liberated when an electron is added to a neutral atom to form a negatively charged ion. Again, we go to chlorine. So what happens to chlorine? Chlorine gains one electron. So after it gains one electron, it completes its octet. But look at this case. This one is neutral because it has 17 electron and 17 protons. It is a neutral atom. But after addition of one electron, even if it has completed a duplet, but it becomes charged. It becomes charged. Now it is a charged ion. It carries a negative charge. So the amount of energy liberated when an electron is added to a neutral atom to form a negatively charged ion. So the transfer of electrons actually costs energy, and it is energetically unfavorable also. The ionization energy is larger than the electron affinity energy. Here, this energy, the ionization energy, is much larger as compared to the electron affinity energy. The energy of the resulting attraction between the ions is larger than the energy cost to transfer electrons. So when an ionic bond is formed, the force of attraction or the energy of the resulting attraction between the ions, between sodium and chlorine, the force of attraction is very much higher than the ionization energy or the electron affinity energy. So the force of attraction actually overcomes these two energies. Which are the two energies? These two energies, and that's why the bond is formed. So we have to now look at the aspect of whether it is exothermic or endothermic. An endothermic reaction is a reaction which absorbs energy. An exothermic reaction is a reaction which releases energy. Okay, the resulting ionic compound is more stable than the ions that is formed. So basically, all the elements which are unstable, they want to become stable. So when they form these ions, when they give electron or when they accept an electron, then they become two oppositely charged ions, and then they come together and they form a compound, and this compound is stable. So sodium is unstable, chlorine is unstable, but NaCl, which is formed from this unstable sodium and chlorine, is very stable. It is so stable that we eat it, we use it in our day to day life. Okay, the extra energy from the ions is released as heat when the ionic bonds are formed. Hence, we can say that ionic bond formation releases energy and is exothermic. So, when that bond is formed, the ions release energy in the form of heat, and then that's what we call it as an exothermic reaction. Exo is exit, okay, thermic is heat. So, a reaction from which heat is given out. Given out. Okay, so exo is basically out, or maybe exit or out, something like that. When more heat is released from a reaction than is needed for it to happen, the reaction is exothermic. So, when you talk about chemistry, chemistry is about making of new bonds and breaking of old bonds. So, whenever it is making or it is breaking, in both the cases, there will be energy transaction. When the new bonds are made, energy is required. When the old bonds are broken, energy is given out. So, when more heat is released from a reaction than it is needed for it to happen, the reaction is exothermic. In the next slide, in this slide, we'll see more of it. Now, if you look at this configuration here, this is sodium 2, 8, and 1. The loss of an electron, so this is a metal, is removal of an electron. So when there's this one electron in the outermost shell, and that needs to be lost in order for sodium to become stable. The removal of this electron definitely requires energy, and that is what we call it as ionization energy. And losing electron is always endothermic. Why? Because you're going to pull away, the electron is being pulled away from the sodium. So that's why it will require energy, it will absorb energy. Something, the energy, when it is absorbed internally and it goes internally into the atom, that becomes endothermic energy. Now the sodium, the electron is being pulled out, and here you will see that there are only now two shells with, sorry, with 2 in the K shell and 8 in the L shell, and it lost one electron, and now it has formed a positive ion. The heat that is required to pull away this electron is this much, 496 kilojoules per mole, and this delta H is the heat required, okay, in this transaction. The gain of an electron, now this is a non-metal, this is chlorine, it is 2, 8, and 7. So this one electron that was lost by sodium gets added to chlorine. So when the gain of an electron happens, and that is also by a non-metal, it is usually exothermic. That is, energy is given out when the non-metal gains an electron and it completes a full octet. So when this one electron is taken by chlorine, you will see that now there are 8 electrons in the outermost shell. Initially this was an unpaired electron, but now it is a paired electron here. So it means that one electron got added. When it got added, there are now 18 electrons and 17 protons. So obviously number of electrons is higher, so it acquires a negative charge because electrons carry negative charge. Now the energy that is given out is this much. Okay, formation of NaCl from sodium and chlorine actually requires the addition of 147 kilojoule per mole in order to turn the atoms into reactive ions. Now, if you take a difference of both of them, you get this value. Okay, so this is actually the energy required for formation of NaCl. This energy was required for formation of sodium ion. This energy was required for the formation of chlorine ion, but an additional energy of 147 kilojoule per mole was required for the formation of a compound, that is NaCl. Okay. Here now I'm trying to show sodium, chlorine. So you see that this one electron jumped from here, from the sodium last orbit to the chlorine's last orbit, and now chlorine's octet is completed. So chlorine becomes minus, sodium becomes plus. Okay. Why? Because sodium initially had 11 electrons and 11 protons, so it was equal. So it means that the atom was neutral. But after it gave one electron to sodium, or after it lost one electron, that could be to anybody, to sodium, to chlorine, or to anybody, after it loses electron, then you get this value. Number of electrons are lesser now. So number of negative charges are lesser than the number of positive charges. Now sodium has become a positive ion. Similarly with chlorine, chlorine is a non-metal. So 17 electrons is equal to 17 protons was before the electron got transferred. After accepting, after gaining one electron from sodium, now it has, well, now chlorine is 18 electron, 17 protons, which is number of electrons is higher, so number of negative charges is higher, hence chlorine acquires a negative charge. And this is an ionic bond, because this becomes plus, this becomes minus, then they both will have a force of attraction. This force of attraction is very much higher than the ionization energy and the electron affinity energy, and they overcome, this force of attraction overcomes other energies, and then you get a compound which is NaCl. Similarly here with magnesium chloride, magnesium is a metal. The electronic configuration is 2, 8 and 2. Chlorine is a non-metal. Magnesium has 2 electrons in the outermost orbit. Okay, so with the 2 electrons it is unstable because the octet is not complete here. Now for completion of octet it will require 6 electrons. So accepting 6 electrons is out of question, but donating 2 electrons is an easy task. So now imagine that magnesium, and there are 2 chlorine atoms here. So chlorine is falling short of 1 electron. Okay, here it is in the outermost, it is 7, here it is also 7. Magnesium in the outermost has 2, so magnesium 1 electron goes to 1 chlorine, another electron goes to another chlorine. Okay, so one magnesium atom donates 1 electron each to 1 chlorine atom, and as a result you will see that now magnesium has completed the octet. Magnesium is stable, it has this moved here and this moved here. Chlorine is also happy and settled because the octet is complete here and in this case also. Okay, now there will be, magnesium becomes positively charged, chlorine, because it has accepted electron, is becoming, both the chlorine will be minus minus, that is negatively charged, and there is a force of attraction, and hence there is a formation of compound magnesium chloride. I hope you have understood what actually ionic bond is. Thank you for listening. Please like, share and subscribe. Thank you.